Folks, welcome to another episode of the Application Security Podcast. This is Robert Hurlbut, and glad to be here with you. I'm a threat modeling architect. I'm also joined by my co-host, Chris.
Hey, Robert, this is Chris Romeo, CEO of Security Journey, and glad to be here to learn something about SameSite cookies, which have gotten a lot of attention over the last 6 months or so. And so I'm excited to dive deep into this.
Same here, definitely so. And so with that in mind, we have our special guest here, Michael Furman. I hope I said that correctly, from Israel. Welcome, Michael.
Thank you. My name is Michael Furman. I am glad to be here. I thank you. You invite me. I will help you, and I will happy to explain about SameSite cookie.
Excellent. And so to get started, what we usually do is we ask our guests to give us a little bit of your security origin story, how you got started in this journey on security. So tell us, how did you get started?
It's a great question, and indeed it's journey. I have started, I think, about 11, almost 12 years ago. I just came to one team in the company called Mercury. And the team leader has asked me, do you want to handle, we have some new framework, the framework called ACG Security. The framework help to our product to handle security. And I say, why not? Because I do like to learn, I do like to understand new issues, new features. And now this framework, by the way, is called Spring Security, is part of Spring framework. And this was my beginning of security, and I have started to learn more and more. And why I do like application security, because required to learn new stuff each day. You know, new attack, new frameworks, new attacks, and it's great journey. A couple of about 6-7 years, I work as a lead security architect at Tufin. And I'm responsible for SDL, Security Development Lifecycle. It's also something very great. It's allow you to change your company to create secure product. And also required to learn like SameSite cookie, like that we have shorter certificate, web certificate. Once again, security is something that you need to learn always. And this is good about security. And before we will continue, a couple of words about Tufin. It's a great company I work for, and it's market leader in security policy automation. And we have a very unique product that help to automate network for thousands of customers, for a lot of customers. And we do help us to our customers in on-prem networks, firewalls, cloud, Kubernetes. It's once again great company, but for me it's very important that give very significant priority to application security. This is my short story of my journey.
Yeah, and I'll definitely second what you're saying about application security. Is certainly something that is changing all the time, and it's an exciting place to be, because if you don't like how things are today, just wait a couple of months and things will be different. There'll be new challenges, new problems to solve. And so our focus for this conversation with Michael is to talk about SameSite cookies, but I thought it would be good to start by, let's define what is a SameSite cookie for those that may be out there that maybe they're developers, they haven't been doing security for a long time, or they're brand new to security. Let's help them to understand, and us as well, what is a SameSite cookie?
Great question. SameSite cookie, it's SameSite attribute. Cookie, when a server instruct a client, for example, a browser, about a cookie, send some attributes. And SameSite is additional attributes. It's like HTTP only or secure. I guess everyone knows what's secure. Secure attribute means that a cookie will be sent only over HTTPS channel. Browser will not send a cookie over HTTP. HTTP only, if a server send an HTTP only attribute, in this case, a browser will not be able to send it via JavaScript. It's only client to server communication. HTTP only, it's also additional attributes. It was introduced by Google, okay, in 2016. And these attributes just instruct a browser. It prevents a browser to send a cookie with cross-site request. Let's say a very common example. It's like you open in one tab your application, and the other application, an additional tab on the same browser, open, like, for example, forum, and the browser will not be able to send a cookie to additional tab because it served cross-site requests. Okay, so it was introduced by Google, by Chrome in 2016, and was adopted in by major browsers in end of 2017. Okay, so it's so this is the SameSite attribute.
Okay, and so SameSite's been around then for just a couple of years, or I mean, was it on the drawing board a few years ago, and it seems like it's the last year where SameSite has gotten a lot more attention, at least.
Yes.
Is that when did Google start even working on this? Do you know?
Because it's more attention because recently Google has changed and introduced a new policy. By the way, I do like Google, and I want to take off my hats and to thank to Google, to Chrome, to increasing security in the world, because it's their zero project, and they do a lot of issues to increase application security. So they have introduced the new policy. It means any cookie, if you have in your application have cookies, so in this case, cookie without any attribute will be threatened as cookie with SameSite lacks attribute. Maybe we will discuss about SameSite in details in a couple of seconds, but the importance of policy is that, let's say you don't need to do anything, and one day you will deploy your application in Chrome, and all cookies in your application will be threatened as cookies with SameSite attribute. It means it will protect against Cserve attack. Okay.
And so that makes sense in terms of some of the things that the reasons why they wanted to put that together. But what are some other things that it's helping you do when you have SameSite cookies in place? I mean, what is it preventing? Again, some of the reasons why we needed to have these in place.
Okay. Yes. Why Google has introduced this cookie? What is protect? SameSite cookie is protect against Cserve attack. Cserve attack is a very dangerous attack, and it was part of OWASP top 10. Now it's not in OWASP top 10, but still it's very important to protect it. And what is Cserve attack? It's allow to an attacker to perform unwanted operation. Okay, and maybe we know the expression that one picture worth 1,000 of words. Maybe I will change it to one demo worth 1,000 of words. I will happy to show what is Cserve attack on a very simple example, and we will better understand what it is. Okay.
Okay, and before we get there, you said Cserve, so that's client-side request forgery, and you mentioned it's off the top 10. I get that question ever so often. Well, it's no longer on the top 10. It must not be an issue anymore. But that's not the case, obviously.
It's obviously, but let's say if someone will steal money from your account or will access from some very sensitive information in your application, and then you will start to explain to your management, oh, it was only on 11th place. I didn't want to take it, to handle it. I'm not sure that your management will be happy with this answer. And of course, customers. I still believe that Cserve, it's very problematic and very dangerous attack that should be prevented. And I do agree that this fact that it was not in OWASP top 10, it's like severity of the attack. It's maybe not critical, but still it should be handled.
Agreed.
Yeah, and I think the last I heard for the previous version of the OWASP top 10, Cserve was actually in the 13 or 14 spot. So it's still relevant. It still exists in applications out there. And I'll just second or third what you guys have already said about the fact that just because it's not in the top 10 doesn't mean we can just say, oh, we don't really care. We don't need to worry about it. Like, it's still a potential vulnerability in our web applications. And if an attacker can use that to get into our system, I don't care if it's number 117 on the OWASP top list. It's still a potential usable vulnerability. So, Michael, why don't you take us to the demo here and show us how cross-site request forgery actually works?
Okay. Okay. I have here a very simple application based on Spring Security. Spring Security, it's a very good framework, and I do like it. It solves a lot of issues. And I just take a demo, and I will show. It's like bank application. And I came to this, let's say I came morning, and I want to, to add banks to my account. I just perform login with this application, my bank, and now I want to add money to my account. Let's say I have 200, and then I just continue to drink my coffee, and I open newspaper in additional tab. Okay, I just open some additional, and what's happened? I will go to my account. I see, wow, I have only 100. Where is my money? Where is my money? This money just was stolen by, by Cserve attack. How it was possible? It was possible because okay, this is example. In this example, we have the same URL to the same bank, okay? And what browser tries to do when he tries to access this URL, it just sends a cookie. Let's see it with our network. If I will show it just cookie, and after the authentication, we can see that our cookie, this is our cookie, okay? And it started with AE and A finished in 8F. If we will go to this application, and we will see that the browser will send the same cookie, AE, because this is functionality of browser. Browser know if you access to this application and a browser having its cookie store a cookie, he will send it. This is a problem. An attacker use cookie, your cookie of your authentication that you use to access your bank, and just uses to access and to steal money from your account. This is Cserve attack.
And so with what you're modeling in the test cserve.html here is, that would be like another site where an attacker had control of the content of the HTML, and they embedded this evil kind of href call here, where it's calling that URL post.html, amount -20. So that would be in this environment, the attacker is in control of another site which has this code embedded within it because the attacker compromised the other site. And then when you load that site normally, you end up with that URL being called and your bank balance being deducted. Is that correct?
Yes, absolutely. The attacker, you want to attack, let's say, all banks in the world, and they try to put, a correct request to steal money from your account. And then they just wait that you will open login to your bank, okay? And then after your login, they wait, you will access to, you know, to some other newspaper or forum or whatever. And this request may be even hidden, you know, you don't have any button, you just open the tab. It was very simple example, okay? But it just shows that the current functionality without CSRF protection, it's vulnerable, and the application, bank application is vulnerable to CSRF attack. An attacker will be able to steal money from your account.
And I think it's important for maybe more seasoned people who might be looking at this and saying, well, you know, that's a pretty simple example and no bank's ever going to expose that level of request in a URL. I think it's important to just say, this is a simple example so we can easily understand it. CSRF attacks in the wild are going to be more complicated, much more complicated than this, but they're going to use the same basic concept to pull off the attack.
Correct. Absolutely correct. The same concept to steal, you know, information, I would sensitive information from an application that don't have protection against CSRF attack. Okay. It can
So
be any. Yes.
yeah, so one of the patterns that we've used in the past to defend against CSRF attacks is the Synchronizer token pattern, where you're sharing this kind of token back and forth
Yes.
between the server and client. Is that still relevant from your perspective, Michael, as a way to protect against CSRF?
Yes. Okay. So regarding your question about Synchronizer token pattern, yes, it's still valid. It's still good pattern. It patterns that used in a couple of frameworks, for example, GSF. Okay, it's out of box. What we have in this, you know, pattern, that browser sent cookie and you use some hidden token, something that an attacker don't know, and each form submit, this token is just refreshed. This is a reason it's called Synchronizer token pattern. So an attacker can have access to cookie, but an attacker cannot have access to a HTTP headers. So and this token should be synchronized every time. So yes, it's very strong pattern, but the problem, it's you need invest a lot to adopt it in if you have a framework that they don't support it, okay? And you know, and it's if it provided out of the box like in GSF, it's great. But if you develop, you know, some API in new modern frameworks like Angular, maybe you want to also to protect against it. And in this case, you need to invest. And in this case, maybe you need to use SameSite, because SameSite is simpler, okay? And okay, SameSite cookie is simpler and also allows protect against CSRF attack.
So it sounds like, so you could still use the synchronizer pattern, but as you said, it's just not as universal in terms of availability. It's not built into all frameworks, so you still have to do some work. So tell us a little bit about, maybe you can demo and talk about how does SameSite help us in this situation?
Yes. Yes, I will start demo that show us how SameSite saves the world, how SameSite protect us against SameSite cookie. Okay. So SameSite cookie, as I said before, it's prevent from sending cookie to third-party site. And new policy that will be enabled very soon will prevent it. Now I have opened configuration of Chrome, okay, and I just can enable this functionality. Of course, I need to restart the browser, okay, and I will open it once again. And what will happen now, as I said before, each SameSite cookie, each cookie will be threaded as cookie with SameSite attribute. Let's try to access our bank once again. Okay, and let's try to attack. And if we will look, you see once again, we have a magic. Only by changing the behavior of a browser to apply new policy, to handle all cookies as same-site cookie, we have protected our application against Cserve attack. Very important, I did not change anything in my application. I just have applied new policy. This policy will be applied, by the way, will be applied very soon. It was planned to be applied in Chrome 18, and it will be applied in Chrome 84. Why? Because of COVID-19. The COVID-19, you know, has a lot of impact on the world, but even on same site, it also has some impact. The policy, the Chrome policy will be postponed to 84. But let's see the difference. It's very interesting to see the behavior. If I will see, and I will try to see once again our cookie, the same cookie AE8F, and now let's see what happens if I will try to see an attack. Okay, an attacker side, and we can see that the cookie is not sent, and we need to, it's redirected to login page. You see, browser don't send a cookie to third-party site, and an attacker need to authenticate once again. And once again, we do suppose that an attacker don't know our credentials. We just try to use the authenticated session, authenticated cookie. Okay. This is a reason that I say that same site cookie just save our world from Cserve attack. It's like this way. Maybe I will elaborate that same site cookie has a couple of values. Okay, the first value is lax. Lax, it's like it's it's fit almost use case. It means it's provide very good level of security, and you don't have a very serious UX impact, user experience impact. It means that you will be able to have links from one application to another, okay, if you want to do it via GET, okay. But in case of like Cserve kind of request, in case of post request, you will not be able to access other site. But once again, we want to save the problem, and we want to provide good UX, so it's better to use Lax, and when it will be used by default by Chrome when you will enable the policy, or when Google will enforce it. Couple of comments regarding other browsers, and we can see it, you know, in this great site, Can I Use? And SameSite cookie by default was implemented in many browsers. If, and by the way, the colors green means it implemented in a very good level. Red, of course, it's not implemented. Okay. If you will see what where is implemented default toolbox, as I said, it will be implemented in Chrome, will be implemented in Edge, Science, Chrome, use Chromium engine. Okay. But it will not implement it in Internet Explorer or Firefox. In Firefox, you will be able to implement it by configuration change. Okay, like similar as we do in Chrome, we have different configuration page in Firefox, and you will be able to configure Firefox to use SameSite. Now I will back to attributes. It's additional attributes. It's called strict. Okay, strict. It's like very strict attributes. In case of strict, browser will not send a cookie even via HTTP GET. It means, let's say you have link, you will have authenticated to your bank or to GitLab or your application, and just press link, and browser will open a new tab, and you still will need to authenticate. Maybe it's good for for banks or very sensitive products, but you need to know that you have strict option, but you need to use it only in case in case of very sensitive application. Okay, and one additional attribute that was added in the new policy was none. What is none? It's like before. It's like cookie without SameSite attributes. And when you need to do it, I just would say it's like last resort. I mean, if you, because new policy will be applied soon, and you need to change your application, and maybe you don't have time to change your application. In this case, you need to configure your cookie SameSite node to be able to behave like before. Like maybe you have like mesh a lot of application in your site, and you will try to apply it and to launch it in new Chrome, it will stop to work. So first of all, it's business. In this case, maybe you will need to configure SameSite node because your application will stop to work. In this case, you have only two caveats. First of all, SameSite node will work only with HTTPS. By the way, HTTP is not secure. I hope we will not have any serious applications that work on HTTP. But the SameSite node, it's only for HTTPS. The second caveat, you see that it will not, behavior in old version, it's not clear. Once again, probably it's not realistic use case that the customer use, its browser that was deployed already, 4 years ago. But still, if you will configure SameSite node and we'll try to open in Firefox or 59 or Chrome 15, the behavior is not unclear. Okay, but this is 3 values on SameSite. And to summarize, the policy that will be provided very soon, where is it? It will be by default 2 lakhs. Okay, it means very good level of security with good user experience.
So if I was to kind of summarize our solution here for cross-site request forgery, I think what we're saying is the Synchronizer token pattern plus SameSite together is going to give us defense in depth. It's going to give us multiple layers of protection against one type of vulnerability. And it sounds like Cserve should be, with these two things working together, Cserve should be something that kind of disappears from the vulnerability ecosystem.
Absolutely.
Nice.
When I just Absolutely agree with you. SameSite cookie plus Synchronizer token pattern, and you can sleep, well, and you will not have Cserve. But as we have discussed in the beginning, we will have new threads. But at least for this one, we can sleep.
Michael, you got anything for SQL injection? I mean, this is such a good solution to eliminate something that used to be on the OWASP top 10. I don't know. Can you give us another cookie for SQL injection, maybe?
It's I will take off my hat once again if Google will provide some attributes that will resolve SQL injection problem. As we know, SQL injection, it's it's on server side, it's more difficult to resolve.
Yeah.
But definitely, it's I would say regarding additional interesting issues that was added to OWASP top 10, it's like serialization, and serialization, it's a very happy, I would say, vulnerability. And according to my memory, CTO of Oracle said that adding serialization to Java was one of the biggest mistakes in Java. And it's like about 40% of vulnerabilities caused by serialization. And this is, it will be very good that we also for serialization, for SQL injection, suppose we have like same SQL or same serialization attribute that will resolve our problem, but
we can only hope and dream.
Yes.
That is a world that we get to in the future. So where is there any resources that you would point folks to? I know we looked at caniuse.com, which I think is a great resource to help you understand security capabilities of individual browsers. So that's certainly one resource. Any
Yes.
other resources that you would point people to as they're trying to understand SameSite as a concept?
Yes, I will try to, as a couple of about me, I do have a post, a blog, and I try to a lot of issues related to security, WireGuard, Ghost Tunnel, everything related to security, Istio, Keycloak, a lot of posts, okay? And if you'll go to SameSite, I have tried to put a lot of resources here, and from OWASP, and from Chrome, and wait a second, and I do believe that, like say, Google will provide a lot of information, but there is a lot of information in my site, and you can see what supported setting before, what is now, what is new cookie policy. I have tried to put everything here, and once again, this is very good blog of Chromium, and it's like Chromium block is very, wait a second, here I have SameSite updates. This is a lot of information I just get from here.
Yeah, it's great. That provides our users with some additional information for those that want to dive in and understand more about SameSite cookies. So that's definitely great. Michael, what do you have any key takeaway or call to action here? Like, if you could give our users like 1 or 2 sentences of action, what are you going to call them to do?
I would say the following. Tomorrow, when you will come and you will wash your hands and you will wear your masks, I strongly recommend to test your application if it will work in a new policy. Just go to Chrome and configure SameSite and try to open to handle all use cases in your application, because it will come and just enable here and ensure that all applications work in all cases. In this case, when it will come in in couple of months, you will be sure that your application work very good. The second, this activities that we did in our company, we have enabled the cookie out of the box in the proactive way. We have configured logs because it's in this case, we don't need to be dependent on browser configuration. So if you can't to configure your cookies to SameSite logs or to SameSite strict, depending on your application, then in this case, you will be protected in all browsers in very simple way, with very good security. So from my point of view, 2 action items: test when in Chrome when policy enabled, and configure your cookies with SameSite logs.
Great advice. Thank you, Michael. Really appreciate you being here with us today and learn a lot more about SameSite cookies and how we can put a little bit more security within our websites and think about request forgery and try to protect against it. So thank you very much.
I want to thank you. It was my pleasure to explain, and take care, and good luck in every issues.
Thanks, Michael.